Okay, so if you have this, we're going to start with example number 1. All of today is really just word problems, or the first page is just word problems. So we'll start off with a word problem. Example 1, we'll jump right in. It says 2 nurses, Kiara and Matthias, drive away from a hospital, and I've even included a picture for us. So if you can see that, let me go ahead and zoom in. Here's the hospital right here, okay? And you can see this little car over here, that's Kiara, and she's driving off into the distance. And you can see Matthias's car, they're driving off into the distance as well, okay? Now, they are going different speeds. Kiara, it says, is going 35 miles per hour. Let me go ahead and highlight that. And Matthias is going 40 miles per hour. So they're going different speeds in different directions. And what it wants me to do is it wants me to express this distance, the distance between the cars, as a function of time. So there's a lot going on. We have this hospital, and then we have Kiara driving away, and we have Matthias driving away. But really what the question is interested in is the distance between the cars. So let me try to draw a little picture. This is the distance that we're actually interested in. And obviously the distance is changing. You know, as these cars continue to drive, that distance between them is going to get larger and larger and larger. So it's going to be changing. It's not like a specific numerical answer, but we are interested in that distance between them. Okay, now let me see if I can try to draw this picture a little bit more obvious. This is actually called a right triangle. Does anyone know of any famous theorems when it comes to right triangles? Pythagorean theorem. So that's exactly what we're going to use to find this missing distance between the two cars, okay? Now, if you don't know the Pythagorean theorem, it's pretty easy. This is side A, this is side B, this is side C, and the theorem is just A squared plus B squared equals C squared. Okay, that's all the theorem is. So if you want to find this hypotenuse, you just use that the squares of each side and add them. So I'm going to go ahead and use that. Now, we're interested in this side C. You can call it whatever you want. You can call it C. In this case, they want you to use D, but it doesn't really matter, okay? So the distance between the two cars, and they're going to call it D of T, okay? Well, it's this formula right here. A squared plus B squared equals C squared. Now, I don't want to know what C squared is. I want to know what just C is. So any idea how I could get rid of this second power right here? If I wanted to get C by itself, how would I get rid of this squared? Square root it. Do the opposite of square, which is square root. So I'm going to go ahead and square root both sides. And in doing so, the square and the square root actually cancel each other out. And we're just left with a C on the right-hand side. Okay, and then I can just copy that over. The square root of A squared plus B squared. So back to my problem. I know I got a lot going on. Oh, what happened? Oh, it's up here. We have the distance between the two cars is equal to the square root of A squared plus B squared. Okay. Now that answer, I mean, it's fine, but we can actually go a little bit more into detail because it does tell me more information. Now, I don't know where like Matthias's car is actually at, but I do know that he's going at a speed of 40 miles per hour. So every hour he travels another 40 miles. So instead of writing the letter A, instead of writing the letter A, I can actually write, well, I don't know how many hours have gone by, but I do know that every hour that passes by, he's going to have traveled 40 miles. So in place of A, I'm going to write 40. I didn't leave a lot of space there, did I? 40H. Okay, because 40 miles every hour, and H is how many hours have gone by. Or you can do T or whatever letter you want to use. I guess I should do T because we're already using T. There you go. And then instead of B, B is how far Kiara has traveled. And I don't know how far she's traveled, but I do know that she's traveling at a speed of 35 miles an hour. So for every hour that's gone by, she has traveled 35 miles. So instead of B, I'm going to write 35T. There you go. And that would be our expression for the distance between the two cars. So if I want to know how far apart are the cars after 2 hours, I would plug in 2 for T. Or if I want to figure out how far are the cars apart after just 3 hours, I would plug in 3 for T. Okay. All right. And then part B is a little weird when it talks about domain in word problems. Remember, domain is just what x value, or in this case, t. We're not using x, we're using t. What values can t, the letter t, be? Now, t is time. So what's the least amount of time that can occur? What do you guys think? What's the least amount of time that we can have? 0. I mean, we can't have -5 hours. So the least amount of time would be 0. Now, there's no maximum for time. I mean, time goes on forever. So we're just going to say time can be anything from 0 and on. And there's a few different ways to write it. You can write it as time can be greater than or equal to 0, and that's it. Or you can just write, I think you might see it on your homework. You might see it like this, 0 to infinity. That's another way to write it. However you want to write it is fine. Or you can just write time has to be more than 0. But that's the least amount of time we can have, and there's no maximum amount of time that we can have. Any questions? I feel weird because I don't see you guys. Okay. All right, let's go ahead. I'm going to go ahead and, I might skip around just for the sake of time. Let me go ahead and see how many problems we have. Oh, no, we have time. Okay, good. I'm glad we have a short set of notes because now we can actually finish. Okay, example 2, very similar. We have a community college has 30 feet of dividers with which to set off a rectangular area for the student center. So think of this college. Here's like the building, right? And they have 30 feet of dividers. So I don't know how they're going to use their dividers, but let's say they use like, I don't know, 15 feet, 15 feet. I mean, that's one idea, right? That's not the answer, but I'm just, that could be what they do. But they're trying to like set off a little, section off a little testing center is what they're trying to do. Okay. All right, if a corner of the math lab is used for the testing center, the partition needs to only form 2 sides of the rectangle. So again, here's this here's this building, this outside building, and let me use a different color. They're just going to use dividers, obviously, for the 2 sides of the rectangle. I mean, they don't need to use dividers on these 2 sides because, well, that's the building, so they already have the walls. So they just need to use this 30 feet for this side and this side of this testing center. So again, they could do a 15 feet here, 15 feet here, or they could do maybe like a rectangle and they could have 10 feet of the dividers here, 20 feet of the dividers here. Again, there's a lot of different options that they can section it off as. Okay. All right. Let's go ahead and answer question A. It says, express the floor area of the office space as a function of the length of the partition. Okay. So we're interested in the floor area. Okay. Now we're interested in the area. Let me use a highlighter. We're interested in the area of the office space. Sorry, I think they're interested in this office space. My bad. Okay, the little testing center. I should have written testing center instead of office space, but it's okay. So we're interested in what's the area, and now this is going to be a rectangle. So the area of any rectangle is length times width. Okay. Now, even though this looks like a square, it could be a rectangle, so don't mind my drawing. But we're interested in the area of this little testing center office space. So the area is going to be length times width. Okay. Remember, they have 30 feet total to use for the length and width. So that's a correct answer, but we can be more specific because we do have 30 feet total. Now, I don't know what they're going to use for the length, what they're going to use for the width, but what I can say is they have 30 feet total. So for my length, okay, like, let me go ahead and write it over here. All right. I don't know. This is my length. Well, whatever they use for the length, I have to subtract it from 30 to get the width because I only have 30 feet total. So let's say I use, I don't know, 5 feet over here, then I would only be able to use 30 minus 5 feet. I would be able to use 25 feet over here. Okay, so instead of writing L and W, I can write L and 30 minus L because the 2 sides add up to 30. So I'm going to go back to my formula, And instead of writing length times width, I'm going to write length times. And instead of width, I can write 30 minus the length instead of the width. And you can leave it like that. I mean, you can also distribute out the parentheses if you want, but that's fine if you left it like that. And there's our area of this little office space in terms of just L's. Any questions?
You could have just put 5 times 25 as your area if you were going to pick 5.
Right. So I don't know what dimensions they decided to pick. I mean, they could have picked 5 and 25. They could have picked 10 and 20. They don't really tell us that. So this function is just basically saying your area is going to change depending on what length they chose. So if they did choose 5, you could actually calculate what area that would be. That'd be 5 times 30 minus 5, and you would get that answer, whatever it is. Okay, 125. But I mean, the area will change. Like let's say they had chosen 10, and so the width would be 20. 30 minus 20, which is 200. So it's not going to be a set area. The area will change depending on what dimension. So we're not trying to say this is the area. We're trying to say this is the area formula. It can be whatever they decide the length to be. It'll change. Okay, but yeah, that is one example of what the area could be. All right, and then the domain of this function, what is the least amount of length we can have? What do you guys think is the minimum length? Okay, if I took a ruler up to this wall and I try to measure it, what would be the smallest number on a ruler I could choose it to be? 0, yeah. So the length can be at the least 0. And technically, I mean, I don't know, it'd be weird if it was 0 because the other side would just be 30 and it'd be a straight line, but it could be 30. And then as far as the maximum, what would be the maximum length? There is a maximum on this problem. 30, yeah, because that's the most they have to use of the partition. So it could be anywhere from 0 to 30. Okay. All right, now this graph, it gives us a graph. I don't think I labeled it, but this y-axis represents the area, and this x-axis represents the length of this office space that they choose. And it says, determine the dimensions that maximize the area of the floor. Now, it's pretty obvious. All you have to do is look at this graph and tell me the maximum area. So you just look for the highest point on this graph, which I've marked out very obvious for us, is this point right here. And so the maximum area, remember, my y value is the area, would be 225. Now, what does this mean? This means that if they chose a length of 15, then they would get the maximum area. So if they do want to get the most area for their buck, I would choose a length of 15. Which means the other side would also be 15. Okay, so maximum area would be 225 square feet. Okay. I'll give you a second to get that down if you need it. All right, those two were the word problems. And then on the next 2 pages, I think it's just graphing. This is where it starts to get a little weird. If you don't have this paper, I encourage you to draw out a graph. It doesn't have to be perfect, but I'll show you what I mean by that in just a bit. Because the graphs on these are going to be pretty useful to have on these next few examples. So if you don't have them, just do a sketch if you need it. It doesn't have to be perfect, but that might be nice. All right, so example 3, what we're going to do is we're going to look at this piecewise function. And this is a little weird. You might not be used to seeing this because usually we just have a function like, I don't know, f of x equals 2x plus 1 or something simple. That's not the case here. If you look here, there's actually multiple parts to it. We have f of x and then we have equals, and it's like a big bracket, and then there's like 3 different lines. I mean, this looks like a lot, right? So there's a lot going on here. This is actually called a piecewise function because there's several pieces to it. Okay, there's actually, to be specific, there's actually 1, 2, 3 pieces to this function. Okay, there's 3 different parts. So it's called a piecewise function because there's multiple pieces. Okay, and the reason why there's multiple pieces is because you're going to use the different pieces depending on what your x value is. See how the second part it says for these x values, for these x values, for these x values. So depending on what x value you're interested in, you'll use the corresponding equation that goes with it. Okay, let me show you what I mean on the example here below. So it wants me to find these different values. Let me go ahead and just start with the first one, f of -5. Now remember, f of a number just means they want the x value to be -5. It's an x. So we're interested in when x is -5. So I'm going to go to this piecewise function over here. And there's 3 different parts. And it's like, I don't know which one to choose. Well, I'm interested when x is -5. So I'm going to look at these different pieces and figure out which piece will I use. Well, x is -5. So I got to figure out where -5 falls under. Is -5 greater than 3? No, so I'm not going to use that one. That one's out. Is -5 between -2 and +3? No, it's not. So that one's also out. So I'm not going to use that one, which means I'll probably just use the top one. Is -5 less than -2? It is. So that means I'm going to use the first equation for this. Okay, so I'm going to plug in -5 for x on this first top equation. So instead of x plus 1, we'll have -5 plus 1. And then we just calculate whatever that is, which the answer is -4. And there's our answer. Okay. Ooh, crazy mess. All right, let me go ahead and do 1 or 2 more, and then I'm going to have you guys do the remaining ones and then check your answers in a bit. All right, I'm going to go ahead and figure out what that next value is, f of -3. Let me go ahead and use a different color. F of -3, that just means they want me to figure out when x is -3, what will the y value be? So I'm going to go to my piecewise function and figure out which one to use. -3, is -3 greater than 3? No. And if you're not sure if it is, what I recommend doing is making a little number line. Just draw out a number line and draw out all your numbers. 1, 2, 3, 4, -1, -2, -3, -4. You get the point, okay? And we're interested in -3. So -3, is it less than -2? Well, here's -2. It's before -2, so then yes, it is less than -3. So I'm actually going to use the first equation once again for this problem. And I'm going to have, instead of x plus 1, we'll have -3 plus 1, which once we calculate that, we get -2. Okay. All right, I'm going to go ahead and do 1 more, and then you guys are going to do the remaining 3 problems. Let me go ahead and do f of 0, because this one's a interesting one. Okay, so f of 0, I want to know when x is 0, what will the y value be? So if I look at these 3 equations, let's see where 0 falls. 0 is not less than -2. 0's to the right of -2, so it's not going to be the first equation. 0 is between -2 and 3. That is correct. Here's -2 and here's 3. So it is between them. So I'm going to use the second equation, which the second equation, it just says 5. There's not even an x. So your answer, you're not even going to have to plug 0 in. It's just going to equal 5. Okay, your answer will automatically, your y value will automatically be 5 if your x value is between -2 and 3. Okay. All right, go ahead and do the remaining ones. You're going to go ahead and figure out what is f of 3, what is f of 4, and what is f of 10. Okay, I'm going to go ahead and walk around if you need help, and then also to check your answers. Oh, let me erase the X outs. Okay, there you go. Yes. Very nice. Once everyone at your table has their answers, if you could check with each other to make sure you all have matching answers.
Yes.
Okay. Oh. Okay, so a lot of right answers. I didn't see very many people get any wrong answers on this one, so that's good. You should have gotten f of 3 is 5. Yeah, that one's weird. You don't have to plug in any x value if you use the second equation. I mean, it's just going to be 5 automatically. And for f of 4, you should have gotten x squared, which was 16, or 4 squared, which is 16. And for f of 10, you should have gotten 100, because we're using that last equation for f of 4 and f of 10. Okay, so 5, 16, and 100. Okay, so that was the first example of what a piecewise defined function is. We're going to be doing the same thing for the remaining examples, except now we're actually going to be graphing them in addition to this. So if you have a graphing calculator already, great. If not, your test is in 2 weeks, so you might want to have one before then. I don't even think I brought mine today. It's downstairs, though. And so even if I had a graphing calculator and I wanted to graph this piecewise function, I mean, I really wouldn't know how to graph that right off the bat. I mean, there's no way to type all 3 lines into a calculator. You could graph it. You would just have to graph it 3 separate times. You would graph the first equation by itself, then the second equation, then the third equation, and try to combine them all. I don't have my graphing calculator, but if I have it next time, I'll show you what I mean. But the best approach to these is graphing them by hand. So we're going to start with an example number 4. And I'll show you how to graph these by hand. They're a little tricky, so if you don't have this paper, I recommend drawing a graph because you're really going to want it. I mean, and also if you are writing in pencil, great. If you're writing in pen, hold off, because the way that I graph these is I draw it and then I erase stuff. So if you're using pen, that's okay, but just hold off until the end to maybe draw some of your graph. Okay? If you're using pencil, totally good. Okay, so let's start on example number 4. I'm going to graph this piecewise function. It's a piecewise function because there's 2 parts. There's a first line and a second line. And I'll use, either equation depending on what my x values are. See, I'll use this top equation if my x value is less than 3. And I'll use this bottom equation if my x value is greater than or equal to 3. Okay? But let me not worry about that second part right now. Let me just focus on the top equation. 1/3 x plus 3. I want to graph that. Let me pretend like that's the only function that I have to graph. So I'm going to go to my graph, and just like we've been doing, I'm going to start with the y-intercept, which is 3. So I'm going to go to the y-axis and go to 3 and mark a point. Okay. And then from there, I'm going to use my slope, 1/3, to help me get another point. So I have 3. I'm going to go up 1/3, 1, 2, 3, and there's my other point. And I'm just going to connect them using a straight line. You can make more points, but I think I'm good with just those. Okay. And again, if you're using pen, I would hold off. I'll let you know when to draw your graph at the end. So there's my graph. Okay. Now here's what I'm going to do now. I'm only interested in this graph when x is less than 3. Okay. Now let me go to the x-axis. Here's 3 on the x-axis, by the way. Okay, I'm only interested in this graph when x is less than 3, meaning before 3. I'm not interested in the graph when x is, after 3. So what I'm going to do with my pencil now is I'm going to erase any part of the graph after 3. Let me use the partial one. So I'm going to go to my graph and I'm going to erase all of this graph after the x value 3, because I'm only interested in the graph when x is before 3, when x is less than 3. And even one more than that, the graph, I'm only trying to graph it when x is less than. This is strictly less than, not less than or equal. That is important, just less than 3. So I want you to also on your graph, I want you to, at the x value 3, I want you to make an empty dot at the x value 3, because you're not including 3, you're just interested in before the x value 3. And so for that reason, we make an empty dot, okay? It might be helpful to make a little note. When you have a less than symbol, you use an open empty dot. If you were to have a less than or equal to, you would use a closed filled dot. Okay. All right, if you are writing in pen, you can go ahead and draw your graph now. I just didn't want you to try to have to cross it out and it become a crazy mess. Okay. But there's our first part of the graph. All right, now we have to graph the second part of this graph. So let me go ahead and let me erase the rest of this. Okay, now I'm interested in just the second equation. So the graph is g of x, or y equals negative x. Now for me to graph this, I'll use a different color. There is no y-intercept. I mean, usually there's a number by itself. There's no y-intercept, which tells me that the y-intercept is 0. Okay, so I'm going to go to the y-axis. I'm going to go to 0. And again, if you're using pen, hold off on this. There's 0. Now my slope is the number in front of x, the coefficient of x. What's my slope on this problem? -1, thank you. There's no number written there, but it's a -1. And you can always write it as a fraction by writing it over 1. So -1 over 1 is my slope for the second equation. So from the point that I've already marked 0, I'm going to go down 1, -1, over to the right 1 and make a new point. Okay. And then I'm going to connect those 2 points with a straight line. Feel free to make more dots if you want, but I'm going to go ahead and just connect them. There you go. Okay. Now, I graphed negative x. I graphed y equals negative x. That's my green line. But what I'm going to do now is I'm only interested in this graph when x is greater than or equal to 3. So I'm going to go to the x value 3, which I've actually already highlighted from earlier. And I'm only interested in this graph when x is equal to 3 or after 3. I'm only interested in everything to the right. So anything before the highlighted part, I'm going to erase on the green graph. Let me get my partial eraser. So I'm going to go ahead and erase pretty much all of this back here. Now you might be wondering, why did you even draw it if you were going to have to erase it? I didn't want, I wanted you to see where it came from. That's why I included that. Okay. So I've only kept the green graph after 3. Now as far as at 3, am I going to do an empty dot or a filled in dot? Filled in, good, because it's x is greater than or equal to 3. So we are going to do a filled in dot. All right, and that's how we graph a piecewise defined function. So pretty much your graph is going to look like a little separated disjoint. It's going to have like 2 parts to it. It looks like 2 separate functions, but it's considered one big function. That would be our piecewise defined function, that entire thing. Okay. Any questions? On a scale of 1 to 5, how difficult would you rate this question? 1 being super easy, 5 being it's super hard. Can I give me a show of hands? Okay. 1 is super easy, 5 is super hard. What do you guys think? Okay. Okay, cool. Thank you. Just want to see where everyone's at a little bit. All right. If that was easy, great. If not, don't worry. The remaining 2 problems are just like this, so we'll go ahead and do, I'll do one more, and then I'll probably have you guys do the other one as or the rest of it as your exit ticket question for today. So let me go ahead, and I'm actually going to jump over to example 6, and then I'll jump back to 5, because that one's a little easier for your exit ticket for today. Okay, but I'm going to go ahead and do example 6 first, and then we'll end with example 5. Okay. All right, example number 6 says to graph this function below, and it's considered a piecewise because there's 2 different parts to it. You can always tell when it's a piecewise whenever there's like 2 lines and they have these fancy, brackets. Now this one's a little bit difficult to graph. I mean, this one's not a linear function, right off the bat at least. But I'm going to go ahead and actually start with the second one because the second one's easier to do, right? Okay. So I want to figure out how to graph f of x, or y equals 3. Okay, really, I'm just interested in, here's y equals 3. Okay, so I'm going to go ahead and just worry about that part. I'll worry about the x part afterwards. Let me just graph y equals 3. Now that one, this is just a constant, so you might remember what it's going to look like. But if not, the y-intercept is 3, so let's go to the y-axis. Let's go to the point 3, mark it. Now there is no x value. Usually there's like a number times x, but there's not here. So what is my slope going to be on this problem when there's no x?
No slope?
Close, not no slope, 0 slope. Think of this as 0x, right? There's 0 x's. So the slope is 0 in this case. Okay. So my slope is 0. You can use 0 over 1 if you want to have a rise over 1, but it'll look like this. You're going to go up 0 over 1, up 0 over 1. So essentially, you're just going to have a straight horizontal line. Okay. That's what your graph will look like for the second equation. I started with the second one because it's going to be easier. Now, as far as the second part, it's only interested in this graph when x is equal to -2. So let me go to the x-axis. Let me show you where -2 is on the x-axis. It's over here. Now, it doesn't even use less than or greater than symbols. It just says we're only interested in this graph at the point -2, when x is -2. I'm only interested in this point. I don't know why I made it such a large circle. Only interested when x is -2. I'm only interested in this single point. So pretty much I can erase the rest of this graph and only leave that single point, because that's all I'm interested in, is that single point when x is -2. Okay, it seems a little weird to draw a whole graph and only keep one point from it, but that's what this question is saying. Okay. All right, I'm done with the second equation. I've graphed it. Now let me go back to the top one, because that one was the more difficult one. Okay. And I'm going to now graph the top equation, which is x squared minus 4 over x plus 2. Now, this one specifically, we haven't even covered how to graph those or what type of function it is. So if you have a graphing calculator already, great. I would use that. If not, it's okay. You still have some time to get one. But what I would do is I would go to your graphing calculator and I would type in that entire function. So you go to y equals and you would type in x squared minus 4 divided by x plus 2 as one whole thing. Make sure to use parentheses around the numerator and denominator when you're typing it in. Okay? And you would just push graph. Now, like I said, I didn't even bring my calculator with me today, but let me go ahead and just show you on Google Graphs what it would look like if you don't have one. Okay, you would just go to, there you go, y equals x minus 2, or x squared minus 4, divided by x plus 2. Actually, I know what that's going to look like. It's actually going to be much simpler than you think. Okay. And this is actually what it looks like. It actually just forms a straight line, okay? And so what I would do is I would just try to plot that from your graph if you have it. But this one's actually a little easier than it seems. Let me go back, okay? What you could do, let me go ahead and write it over here. Oh, let me use a different color. Okay? So you could, that's one option. You could use your graphing calculator, go ahead and graph it, and then just try to plot some points from your graphing calculator onto the paper. That's one option. Your second option, and this one actually, it's the by hand method, but it's really not so bad. Let me just rewrite this problem. We have y equals x squared minus 4 over x plus 2. Okay? That's what the problem is. And I wanted to graph it. Now, this top part, this numerator, x squared minus 4, if you're familiar with factoring, that one does factor. It's called a difference of squares. If you had me last semester, you know what I'm talking about, hopefully. X squared minus 4, remember, that's the same thing as x squared minus 2 squared. That's called a difference of squares. So you can factor the numerator as x minus 2 times x plus 2. And if you're wondering, where did you get that from? I encourage you to review factoring. So that's where I got that from. And the denominator, I didn't have to change. That still stays the same. Okay. All right, and the reason why I did that is because if you look at this fraction now, you're actually going to see something cancel out on the top and bottom of this fraction. You have an x plus 2 on the top and bottom of this fraction, so those will actually cancel out. And all you're left with is just the y equals an x minus 2. And that's actually really easy to graph. We know how to graph that. That's just a linear function. And so I can easily graph this function. Now, I mean, I didn't know how to at first because it looked like a crazy function, but it's actually not so bad. It's just a straight line. So I'm going to go ahead and graph this now by starting with the y-intercept, which is -2. So I'm going to go to the y-axis, go to the point -2 on the y-axis. And then from there, I'm going to use my slope. Now, what's my slope on this equation? 1, or 1 over 1 if you want to write it as a fraction. Thank you. And so from the point I've already marked -2, I'm going to go up 1 over 1 and mark another point. Okay, feel free to get more points if you'd like. But once you have all your points, just connect them using a straight line. Okay. Whew. There you go. Okay, cool. Now there's my line y equals x minus 2. Now back to this piecewise part. It's only interested in this graph when x is not equal to -2. So I can graph this pink function pretty much anywhere, except when x is -2, it doesn't want me to include it. So I've already kind of highlighted the x value -2. That's right here on the graph. And I can graph this pink function anywhere except not at -2. So when I go to -2, which is right here, I'm going to basically erase that part from the graph. And a better way to write this would just be like an empty dot, because you're not going to include the graph when x is -2. Okay, that's what this means. It says you're going to graph it. Woo. Darn it, what did I just do? You're going to graph it when x is not equal to -2. Okay, that one was a bit more difficult. I think that was probably the more challenging one of these notes. So I wanted to cover it in case you see it on your homework. Okay. Okay. All right, guys. The last one is going to be like your exit ticket question. I'll start you off on it to help you, but then this will be your exit ticket. If you don't have this paper, again, just do a rough sketch of it on a graph. Doesn't have to be perfect. I'll start you off on one or two of the functions, but then you guys will graph the rest. Okay. And again, I'm not looking for a perfect sketch, just a rough drawing to see that you get the idea. Okay. All right. It wants me to graph this function. Now, this is a piecewise defined function, and it's consisting of 1, 2, 3 parts. So I'm going to have to graph three different lines on this graph. Let me go ahead and just start with the first function, okay, which is f of x equals 4. So if I wanted to graph, this is just y equals 4. Well, I kind of already did one like that on the previous example, so I already know what it looks like. That just means you're going to go to the y-axis, go to 4. That's your y-intercept. And the slope is 0, so it's just going to be a flat horizontal line. Okay. There's my first function. But I'm only going to graph it when x is less than or equal to 0. So let me go to the x value 0, and I'm only interested in this pink graph when x is less than or equal to 0. So pretty much anything before it, that's what I'm interested in. Everything else that's after 0, I'm not interested in. So I'm going to just erase all of that part from the graph. There we go. So everything after 0, I'm not interested in. I'm only interested in stuff that's less than or equal to 0. Okay. Now, as far as at the point 0, am I going to keep this point a filled dot, or am I going to make it empty? Okay, this is a less than or equal to symbol, and that means that you will use a filled in dot. So I'm going to keep it filled in. Okay. All right, let's move on. I'll just do the second one for you, and then you guys will do the last part of this, okay? So I'm not leaving too much for you. All right, the second part of this function is 4 minus x squared, which again, we actually haven't covered graphing quadratics. I mean, you might have in a previous math class, so you might already know how to do that. But if not, again, I wanted to do it with you. This is just like graphing y equals 4 minus x squared. And again, you can use your graphing calculator if you have one, or you can just plot some points by plugging in random x values. But I'll just tell you what it looks like. It looks like this. I'm going to use, I think you'll be able to see it here. I'm going to use red. Okay. It's not perfect. Okay, this is just a rough sketch of it. Okay, that's what it looks like, roughly. Okay. Now, I'm only interested in this graph from 0 to 2. So go ahead and finish this rest of the graph. You're going to have to erase what you have to. And then you're also graphing the last one. Okay, so go ahead and do that. Let me know once you have your answer, your full graph. I'll just quickly check it. And if it's right, you are free to go. If not, I'll help you stay afterwards and complete it. Okay, give me 1 second.